Bismillahirrahmanirrahim. Assalamu alaikum. About me. My name is Hafiz Talha Habib. My registration number is 17 NTU 1122. I am from BSCS Morning 6th semester and my topic of presentation is image acquisition using sensor arrays. Now here I discuss overview of my presentation. Before start my topic, in overview I discuss some topics. What the first one is what is image in digital image processing, the second is what is image acquisition, how, and the third is how is image acquisition done, the fourth one is what are image sensors, and the fifth is types of imaging sensors, and the last one is image acquisition using an array sensor. That is my topic. Now here I discuss what is image. An image is a visual representation of data is called an image. Anything in your data, when you see your data visually, it is called an image. Now we will move to our topic, digital image processing. What is an image in digital image processing? An image is defined as a two-dimensional function f of xy where x and y are spatial coordinates and the amplitude of f at any pair of coordinates xy is called the intensity of that image at that point. When x, y and amplitude values of f are finite, we call it a digital image. Here x, y, we can also say that these are the coordinates. The x coordinate is the horizontal coordinates and y is the vertical coordinates in our data. That's why we can see that an image by using x and y coordinates. This is very important topic in digital image processing, that what is an image acquisition. We know first we have to acquire an image. If we have image, that after that we perform some operations on it. But if we don't have an image, then how we can remove the noise from our image, how we can enhance our image quality, and how we can collect data from our image. That's why whenever we have to perform an operation in digital image processing, every time we need to acquire an image. In image acquisition, actually now we move to image acquisition. What is image acquisition and how we can acquire it? Here in image acquisition, it is defined as the action of retrieving an image from some source, usually a hardware-based source for processing. We know whenever we have to acquire an image, we need an hardware. We need, if we have a hardware like camera, computer, printer, or any other hardware, then we become able to acquire that image. Actually it is the first step in the workflow sequence, because without an image no processing is possible. The image that is acquired is completely unprocessed. Now we know about what is image acquisition. Here we discuss how is image acquisition done. I explain here with explanation as well as with diagrams. The explanation is the incoming energy is transformed into a voltage by the combination of input electrical power and sensor material that is representative to a particular type of energy being detected. The output voltage waveform is the response of the sensor, and a digital quantity is obtained from each sensor by digitizing its response. Here we can see in diagram. Here this is an energy, and here we have some source, some sensing materials. Here under processing, here we apply a power, and here a voltage waveform out. This voltage actually is the response of the sensor. These checks the response of the sensor and gives us an output to knowing about how's our sensors condition. Then after that, when we collect data from our image, then we process some operations on it. Here now we discuss some image sensors. Actually, in digital image processing, there are three types of image sensors. The first one is single image sensor, second is line sensor, and third is array sensor. Actually, single image sensor sends the image through row by row in some chunks of data, in some pixels of an image, and line sensor is better than single image sensor, and it collects data in image through a complete line. And array sensor, we discussed about array sensor in detail in the next slide. Now here we discuss array sensor in with detail. In this, individual sensors are arranged in the form of a 2D array. This type of arrangement is found in digital cameras, for example, CCD array. Here, in this, the response of each sensor is proportional to the integral of light energy projected onto the surface of sensor. Noise reduction is achieved by letting the sensor integrate the input light signals over minutes or ever hours. Now, here we discuss sensor array visually. Here we have some scene element that we have to need to perform some operations on it, and here I have illumination energy, some source of light we can say we throw on it, and we have here number 3 at imaging system. This is an imaging system, and here we have image plane. This is actually works internally. Here we have image internal plane, and internally our image looks like this, and here we got an output digitized image. Here we can see small boxes. Each boxes is called a pixel. We collect data digitally in the form of pixels because that we know we use a sensor array. Here we collect data and we apply sensors, we apply array sensors here. That's why we have data, output data in the form of these matrices and in the form of pixels. Now we discuss advantages of using an array sensor. As we know, we have two other methods that we discuss in previous slides, but every method has advantages as well as disadvantages. But array sensor is very useful in digital image processing to perform some operations on an image. Here we discuss some advantages. The first one is, since sensor array is 2D, a complete image can be obtained by focusing the energy pattern onto the surface of the array. In first point, I explained array sensor completely sense an image, completely sense the image completely through a one time. And we know line array and other method, other sensor arrays, they can't perform operations on an image completely at one time, but array sensor works very well and process complete image in just a single time. This is the very useful and great advantage of using an array sensor. In the second point, we discuss the sensor array is coincident with the focal plane. It produces an output proportional to the integral of light received at each sensor. Here we need to know, this is very useful information in second point, the output we got using array sensor, that it produces an output proportional to the integral of light received at each sensor of an image. That's why it is very useful, and got our data, and that's an image, that we can get after operation on it. This is very useful information, and the data we can get is very helpful, and we have easily perform any operation on it, like noise removing, image enhancement, and collects data of it. In the last point, this is the third point, digital and analog circuitry sweep these outputs and convert them to a video signal, which is then digitized by another section of the imaging system. The output is digital image. In third point, I can say digital and analog circuitry sweep these outputs. First, when we complete our image processing, it sweep the outputs and convert them to a video signal, which is then after digitized by another section of the imaging system. Then we get the output in digital form, and this is output is digital image. These are the very useful and very great advantages of using an array sensor on an image in digital image processing. Jazakallah sir, I hope you like my presentation. Assalamu alaikum. Allah Hafiz.